All right, so let's talk about the slope of a line. Notice the two lines on this page. The blue line is A and the red line is B. And so whenever we talk about the slope of a line, we're talking about the steepness of that line. And how we do that is we compare the vertical to the horizontal. Okay? So line A has a steepness of 16 to, and remember we're dealing with line A, to 8, so it has a slope of 2. Line B has a steepness of, they're both 16 feet tall, so 16 feet over, in this case, 4. So 16 divided by 4 is 4. So line B, because the number is bigger, and we're really looking at the absolute value of the number, because if it were a negative slope, we would strictly compare the absolute values. So line B is steeper because the number is larger. Okay, so this page is just reiterating what I just said. You are comparing your vertical distance to your horizontal distance. And the object with the larger ratio is the steeper object. All right, so on this page, we are comparing the steepness of two roads. A portion of road A climbs steadily for 120 feet. That's the vertical distance, over a horizontal distance of 4,250 feet. Remember, you do vertical over horizontal. So we're going to compare 120 over 4,250. I don't know about you, but I don't do that kind of math in my head. So I'm going to, on my calculator, type in 120 divided by 4,250, and I get this big long decimal that I'm going to take out to several decimal places. Okay, I'm going to stop there. Okay, so now we're going to look at road B. It climbs steadily for 95 feet. That's our vertical. Over a horizontal distance of 2,875 feet. So then I'm going to, on my calculator, type in 95 divided by 2,875, and I get okay, so now I compare. That is the same as that. That is the same as that. Oh, look at that. This one is actually bigger, so this one is my steeper road, road B. Okay, so if you take a look at this page, you'll see that we came up with, they rounded their decimals to a different spot, but nonetheless, they also came up with road B being the steeper road. It's not much steeper, but it is steeper. Okay, so whenever we talk about the grade of a road, the grade of a road is the ratio of the vertical distance to the horizontal distance. Does that sound familiar? It actually should. It sounds a lot like slope. So the difference is, whenever we talk about grade, we're talking about a percent. So if you go back to road A and road B, we would turn those decimals into percents. So this, as a percent, road A would be 2.8%. Road B would be 3.3%. So that is the grade of those roads, percents, 2.8 and 3.3. Okay, so if we talk about just a generic line, we're not talking about roads, we're not talking about mountains, we're talking about just a generic line, then, again, slope, they use the letter M for slope. That's pretty much in every textbook I've ever seen is using the letter M for slope. So you are still talking about vertical change over horizontal change, or vertical change divided by the horizontal change. You may also hear it as rise over run. So the slope of a non-vertical line is equal to the ratio of the rise to the run. We use the word change rather than distance because the sign is important. So yes, a positive slope is different than a negative slope, but the steepness could be the same, it's just we're talking direction then. Okay, so let's take a look at this. And notice how we keep saying non-vertical line. Non-vertical lines have a different slope, and we'll talk about that later. I'm sorry, vertical lines have a different slope. We will talk about that later. All right, so if I am comparing or trying to figure out the slope of this line right here, let's see here. I'm looking at this point to this point. Then I count the distance, the rise over the run. Again, I can't tell by this graph how far it is, so right now I can only tell you in generic terms that the slope of this line is the rise over the run. This is a great handy dandy little formula for you for slope down here. Really, it's this portion right here. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Where did we get y sub 2 from? Well, it's the y in your second point. The y sub 1 is the y in your first point, and you subtract. So we're talking about the change in y's over the change in your x's. Notice how the subscripts doesn't mean I multiply by 2. Do not multiply by 2. It is a name. Subscripts are a name. I'll show you what I mean here in just a second. Okay, so now I want to find the slope of the line that contains these 2 points. Now, I'm going to name this first point x sub 1, y sub 1. This is my x coordinate, the 2 is my x coordinate, the 3 is my y coordinate. I'm going to name the second point x sub 2, y sub 2. I'm going to do this problem 2 different ways. I'm going to show you that it doesn't matter how you name your points. Okay, so on the previous page, they gave us this formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1, or the change in y's over the change in x's. My recommendation is, because we won't always have positive numbers, my recommendation is to do this. Parenthesis minus parenthesis over parenthesis minus parenthesis. That way, people tend to lose their negatives if they don't do the parentheses. So what goes in this position right here? Y sub 2, which is 5. What goes in this position right here? It's y sub 1, which is 3. The bottom left is x sub 2, so I'm going to put an 8 in there. And the bottom right is x sub 1, which is 2. Now I'm going to do the math. Again, because of positive numbers, this isn't difficult math, but sometimes people get confused with negatives. Okay, so I'm going to simplify the numerator. 5 minus 3 is 2. The denominator, 8 minus 2 is 6. I'm going to reduce. 2 over 6 is the same thing as 1 over 3. So the slope of this line is 1/3. Alright, so now, here's what I'm going to do. I'm going to erase the names that I've given these points, and I'm going to name this one x sub 2, y sub 2, and this one x sub 1, y sub 1. Again, I'm going to use the same formula. So I'm going to do parenthesis minus parenthesis over parenthesis minus parenthesis. Now, in the top left position is the y sub 2, which in this case is 3. In the top right, the y sub 1, which is 5. In the bottom left, we're going to put in the x sub 2, which is 2. And the bottom right, we're going to put in the x sub 1, which is 8. Now, let's subtract. 3 minus 5 is negative 2. 2 minus 8 is negative 6. Negative divided by negative cancels, so I'm left with 2 over 6, which is 1/3. Lo and behold, we came up with the same answer. So it does not matter which one you name x sub 1, y sub 1, or x sub 2, y sub 2. Just make sure that the numbers should line up. Let me show you what I mean by that. The 3 and the 2, because they're together right there, you put your y's over your x's. The 5 and the 8, because they go together, y's over x's. Same thing up here, 5 and 8, 3 and 2. So make sure that you keep your x's, your x and your y pair together. If they're on the left position, you keep your x, y together in the right position. Okay, so here's the solution in a graph. So they graph the point 2, 3 right here. They graph the point 8, 5 right here. Your vertical change is 2. Your horizontal change is 6. And again, we always reduce our fractions. Okay, lines that go upward to the right are increasing. So read your line from left to right. If it's going up, then that is a positive slope. Read your line from left to right. If it's going down, then it will have a negative slope. Okay, so on this page, we're going to compare line 1 to line 2. All right, and which one has the greater slope? So let's look. Now, they both have a point right here. They're both going to start right there. Look at line 1. I can put another dot right there. Line 2. I have a starting place at the same point, but that point, the second point, is right there. So on line 1, I have up 1, right 1. That's 1 over 1, which is a slope of 1. On line 2, I go up 1, 2, 3, up 3, to the right 1. That's a slope of 3. So line 2 is steeper. Alright, so let's compare these. This graph looks like a hot mess. But let's just look, for instance, at the blue lines. Okay? Notice how I'm going to put a star on this one and let's say a rectangle over that one. Okay, so the blue line with the star above it has a slope of 2. The blue line with a square above it has a slope of negative 2. Now those actually have the same steepness, but their slopes are different. In this case, the difference in the slope tells you the direction that it's going. Okay, so in the negative 2 slope, it's going downwards to the right. In the positive 2 slope, it's going upwards to the right. So they do have the same steepness, but their slopes are different. The sign indicates the direction. The absolute value of the slope indicates the steepness. Okay, so let's take a look at this slope. Again, we're going to use the formula y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I'm going to name this x sub 1 y sub 1, x sub 2 y sub 2. So, what goes in the upper left? Upper left is going to be 2. Upper right is also going to be 2. Bottom left is going to be 7. Bottom right is going to be 3. Now I'm just going to do the math. 2 minus 2 is 0. 7 minus 3 is 4. Now, you can either take my word for it, or you can know that 0 divided by 4 is 0. So this guy has a slope of 0. Now, a slope of 0 means that you don't go up or down any, but you can go left or right all day long. So that means that this is a horizontal line. Let me show you on a graph. So here's the point 3, 2. Here's the point, 7, 2. This is a horizontal line, and it has a slope of 0. All horizontal lines have a slope of 0. Alright, so let's take a look at this one. Again, I'm going to use the same formula. I'm going to call this one x sub 1, y sub 1. This one's x sub 2, y sub 2. So I've got 5 minus 1 over 3 minus 3. 5 minus 1 is 4. 3 minus 3 is 0. You are never allowed to have 0 in that denominator. So having 0 in the denominator means that this slope is undefined. Alright, so let's take a look at this graph though. If you were to graph the points 3, 1 and 3, 5, look at this. 3, 1 is right here. 3, 5 is right here. That is a vertical line. All vertical lines have the same slope. The slope of this vertical line is undefined. Alright, so this is just a generic page letting you know a horizontal line has a slope that is equal to 0. A vertical line has a slope that is undefined. Alright, that's it. So have a good day.